Alright, so question 2 here, we're dealing with nomenclature, and specifically we're dealing with nomenclature of alkenes and alkynes. But always remember that everything else we've learned with nomenclature still applies. So first question, what's our longest chain and which direction do we need to go? Well, longest chain here should be pretty straightforward. It's the chain that's going right down the middle. And we know in this case that we need to go left to right. Why is that? Well, the location of any alkenes or alkynes takes precedent over any substituents. So we pick the end of the chain that's closest, that has an alkene closest to the end. So this is a 9-carbon chain. We know 9 carbons is nonane. But since it has 2 alkenes, one starting at 1, one starting at 6, this will become nona 1,6-diene. The next thing we need to do is we need to name each of the substituents. As we've done many times in the past, we could make a list. 1-chloro, 3-chloro, 5 has an isopropyl, 6-ethyl, and 8-iodo. So now we can alphabetize those. 1,3-dichloro, and combine any that are alike. 6-ethyl, 8-iodo, 5-isopropyl. And then we can bring back down our parent name that we already determined to be nona 1,6-diene. Are we done? We are not done. What do we still need to do? We need the stereochemistry. And remember, that means not just E and Z. That's what's new here compared to exam 3. But we also need R and S. So if we look at our first alkene, the one that starts on carbon 1, we could put the 2 hydrogens in, and we can see that the higher priority substituents are on opposite sides of the alkene, and so that makes it E. And let me make a correction. This alkene here actually started on the 5th carbon, so let's get that correct. That second alkene that starts on the 5th carbon, where are our higher priorities? So we have a carbon bonded to a carbon versus a carbon bonded to 2 carbons. So we have higher and lower. Here we have a CH2 versus a CH2, but then we have a CH3 versus a carbon with other substituents. So we have higher priority down here. Our higher priority substituents are now on the same side, so this alkene would be Z. Now, what about the stereocenters? At carbon 3, we have a chlorine, which is higher priority than either of the carbons or the hydrogen. This is considered a carbon bonded to 2 carbons because of the double bond. On the other side, we have a carbon bonded to 1 carbon. That'll be lower priority. The lowest priority, the hydrogen, is already pointed back. So here we're going clockwise, or R. And finally, at carbon 8, the iodine is highest priority. The long chain is second. The methyl is third. Goes counterclockwise, but because the lowest priority, the hydrogen, is pointing forward, we take the opposite, which is R. And so there we have the full name of our compound: 1E, 3R, 5Z, 8R, 1,3-dichloro, 6-ethyl, 8-iodo, 5-isopropyl, nono, 1,5-diene. This next molecule may be a little bit more straightforward. We don't have any RS stereochemistry to worry about, but we do still have E and Z from the alkenes. Now we start at the end of the molecule, the end of the chain that has the pi bond closest to the end. That means we start over here at the left with the alkyne. The reason for that is if we started here, our first pi bond doesn't come till the third carbon. So this is a derivative of decane. But we have two alkenes and two alkynes. Alkenes always come first in the parent name. So we have 3,7-diene. And then the alkynes start at 1 and 5, so it's 1,5-diene. Our next step is to name any substituents. That's probably the easiest part of this question. There's only the two methyl groups at carbon 9, 9,9-dimethyl. And finally, we need E and Z for the two alkenes. In both cases, we should be able to see that the hydrogens which are not drawn in are on opposite sides, and therefore the higher priority substituents are on opposite sides as well. And that means that both of these, the 3E, as well as the 7 alkene at 7, is also E. And there we have our final name.